Hello and welcome everyone, this is Mainak and today we're going through a tutorial on the updated process of the working mechanism in Etabs software as per the latest IS codes, and we're going to be applying the seismic load in zone 5 and also the wind load as well in consideration. So first of all, we open the new file and everything is in Indian ecosystem, and we can create a default grid here since we are just taking default structure here. Number in the x direction, number of grids in the y direction, x direction. We'll just take here, let's go with 4 in each direction, and spacing also let's go with 4. Number of stories, let it be bottom story height, let it be 2, and typical story height 3.2. number of stories, let's say 3, and let's create a model here and click on OK. The model framework will be created, and let's go finish with the modeling part here, because I don't think we have any problems with the modeling part. So let's finish that. We'll finish that, but basically we'll just define the materials first. Go to materials, you'll find some default materials here, so we'll add new materials as per our Indian code. Select India from this list, and first of all we'll select concrete, and we'll go with M25 here. You can select any grade of concrete which you want, M25. Click on OK because these are all checked, no need to check again, and go again India, and this time we'll go by rebar, and this will add the 500, which is the most commonly used material right now. We have higher grades as well. So once these two materials are added, we do not have any actually option to make this as a default material, otherwise it would be nice. We should. This is a suggestion to CSI. Okay, so this manufacturer of the software. So just press on OK. Sometimes it doesn't come, so again twice check that whether the properties which you have inserted are showing in the defined material section or not. So if it's showing, then it's fine. Just click on OK, and after that we're going to go to the next section. Define material is done, and define sections. So now we want to define a single section for beams and columns. Practically in projects you have to define multiple sections here, but let's define a default section for beam and column here. So we can just have this A gravity column. We can just kind of edit this, okay, modify this property just to accommodate the things here. Okay, so yeah, so let's modify this property. Okay, I think, okay, concrete column, sorry, concrete column, my bad, concrete column. Let's edit this concrete column. So in place of concrete column, we'll just write the name as C, let's go 450 cross 450 for the column size, and material will be M25, fine, and here change this to 450. So you can see by default you have this a number of bars in 450. So you can see 1 to 3 to the 6, and again 6 plus you have 6, that is 12 number of bars can be accommodated here, which is clearly being shown here. Okay, so property modifiers. So we have the moment. If you just consider this moment in the x and 2 directions. So for the columns in the crack section property consideration, this is 0.7 and 0.7. I think I'm obliged to show the IS code for where it is done. It'll make the video a little bit longer, but it's fine for those who are watching for the first time, just for an reference here. So you can check here just this note which I actually gave out to you in most all of my videos. The link to this just prepared shortcut to some of the important clauses in the IS 1893/2016, which is the latest code as of now. So in clause 6.4.3.1 you find the structural analysis. The moment of inertia shall be taken as 70% for I gross of columns and the 35% for I gross of beams. So that's the consideration which we are taking here. That's since we're designing columns, so we're taking 70% of the moment of inertia. So if you have any additions to that, you can write in the comments. So that's what we're taking. Just click on OK. And reinforcement here, you need to change the grade here to HYHD 500 because this is the grade which you are using here. Only since we add just editing the column, so that's why we don't have to change this. Otherwise, if we just add a new material, new property, then we have to do this. That like click on this column. And the other things, we're just going to keep this as usual. You can change this if you want. And then now you can just click on OK for the columns here. So concrete beam, just double click on this to edit this. So we'll just go B 250, or let's go 1 for all. So let's go 300 cross 600 for the beams. And the property which you're going to give is M25 property, and width 300 and depth 600. You will notice that like in column the number of rebars appear, but in beams that is not the case, because in beams you can have multiple layers with the help of your spacer bars of 25 mm. Property modifiers same for beams as per the standard. It is 35%, moment of inertia about 0.35 and 0.35 is the moment of inertia here. And this is done. And reinforcement, obviously just change the grade to which we are using here, and cover to longitudinal rebar centroid. We'll just can change this later because this is mainly detailing part. So we'll just keep this as default and click on OK, and then click on OK. And then again we'll just check here, because it's always, I tell you, in double check to see whether the changes we made are saved or not. Sometimes we don't press OK and it is not saved. Okay, spring section properties, soil structure intellection, we'll not doing this right now, so we'll ignore that. Now as of the diaphragms here, so in the plinth level, and we have this let's say first floor, and we have the second floor, so, or the terrace. So in the plinth level, if you provide the plinth beam slab, then you need to take the diaphragm here, and it doesn't hurt to take, but at least we have two levels here. Plinth level, let's not assign any slab, these two levels we'll assign two diaphragms. So let's define the two diaphragms here. Diaphragm T1, and we'll add new diaphragm here. Always add a rigid diaphragm. Semi-rigid diaphragm are for some special cases. Now again, I feel obliged to show you some of the codal references for the diaphragms. So let's see if I can do that. So here's the clause: the flow diaphragm shall be considered flexible if it deforms in such a way that the maximum lateral displacement measured from the chord of the deformed shape at any point of the diaphragm is more than 1.2 times the average displacement of this entire diaphragm. So this is a special case. So where the diaphragm are considered to be flexible. So we have to after the analysis we have to check like whether this thing is occurring, like if a flow diaphragm at the maximum lateral displacement exceeds more than 1.2 times the average displacement. So we have to do after the analysis. So for starting we need to consider a rigid diaphragm, and also in buildings which we have large openings also, then also sometimes we have, you see here it is written, usually reinforced concrete monolithic slab beam floors or those consisting of prefabricated precast element with reasonable reinforced concrete 50 mm can be considered as providing rigid diaphragm. So normally in general cases, or we are considered all slabs are considered as rigid diaphragm, but in special cases due to plan irregularities, due to openings, etc., the diaphragm may be considered as special or flexible. Okay, so we have two diaphragms defined for the two floors in which the slabs will occur, and then pier levels we're not giving here. Spandrel levels obviously need this for lift definition. Group definitions also we're not doing, and I'm going serial by so that we don't forget the things here. And response spectrum definitions, we'll do this. Response spectrum definitions, generalized displacement definitions you can do. Not use your mass source, we'll use here P delta options, will not use your model cases. We'll use that model cases here for the response spectrum definitions. And let's first define the load patterns. So we'll go to load patterns, and then we'll go like this: dead, alive, and we have the self weight multiplier with the dead load. So we'll add a new load here. We'll keep all the self weight in this, and another load case will create, and this will call the other dead, and in this all the other dead loads will add, self weight multiplied 0, and click on add new load, and then we'll create the seismic load in two directions. So if you are just following me for a long time, in this, in seismic zone 4 and 5, compulsorily for any sort of building we need to apply the seismic load in vertical direction as well. But in Etabs, in this version, current version 2022 to 2016, since we don't have the latest code here, so we can only apply this in the static load in two direction. Dynamic, there is a way in which we can apply the dynamic load in three directions. We'll show you that. So let's go ahead. If you find anything, any new option, you can just tell me. There is option to add the static load in the three directions in the latest versions of Etabs. You can just let me know. Okay, so we'll select the code. As you can see, 2002 is the latest code of here available, but as of till date, the latest code which is available is 2016, 2016. So seismic load in X direction add, and seismic load in this other lateral direction is Y here. In STAAD.Pro it was Z, so it is Y here, and click on add new load here, and X and Y added, and then we'll add the wind load. So the latest wind load is available here, so no problem in that. So we'll add the wind here, and we'll go with the 2015, the latest wind code which is available here. Add new load. Okay, the dead load, live load, don't really need to do anything. Seismic load, we need to modify this. This is only in the X direction, and this zone factor depends on the where your site is located. Our site is located in zone 5, so as per the code table number 3, the factor is 0.36. so if you are in seismic zone 5, it is 0.36. if you are otherwise, do as per table number 3 of the code. So then the site type is 2123. So this basically is the type of soil in which you are resting your foundation here. So there are three types of soil mentioned in the code. So you have three types of soil mentioned in the code here. So hard, rocky, and soft. So you can see here, so rocky, medium, stiff, and soft. So if it's medium, then it is type 2, and if it's rock, then it's So you have this here in table number 4, page number 13. Type 1 soil is rock hard soil, type 2 is medium stiff, and type 3 is soft soil. So depending on the n value, you can find a type of soil. So you need the soil test report for that. So I'm just going with type 2 here. See the soil test report and decide the type of soil which should be mentioned in the soil test report itself. So here I'm going to go with this, and we'll go time period program calculated here. By the way, if you want to calculate the time period manually as well, so that's also mentioned in the code. In STAAD.Pro we do that, in Etabs also you can do that, and you can just calculate this. So basically you will need the time period. So for the time period you need the building height and the dimensions here. So our building will be in type C, that is all other buildings. Type 1A building is RC frame without masonry infills, means without any walls. Since our structure will have walls, so it will come in all other buildings. So this will be the formula. This is H, and this is the dimension, largest dimension in the particular direction. So X and Y dimensions you'll need. You will calculate this time period like this example, and then after calculating time period, you can also calculate the acceleration also. AH for acceleration, this is the for the vertical direction, this is the formula, and for the horizontal direction, this is the formula here. So if you follow my STAAD lecture, so you can or blogs, you can just find that out. But for now this is not required. We'll just go with program calculated. So let the program calculate this for the code, and then we'll just click on OK, and here also modify lateral load. This will be in the Y direction only, and 0.36, and site type 2, and then importance factor I skipped. Yes, importance factor I skipped to explain. For the importance factor, you need to look into table number 8 of the code. So I'll just zoom in so that you guys can have a better view. So for all other buildings it is 1. If building has more than 200 occupancy, it is 1.2. If it is an important government building, then it is 1.5. So for us we're going with 1.1 in the previous case also, in this also. And bottom story, you can keep this as the plinth level. Okay, So this also I'll just modify this and keep this whatever the plinth level is, you can keep this as a bottom story. Okay, and response reduction factor is always 5, damping ratio is 0.05. So now this is the wind load here, modify lateral load, wind load, and we'll just go exposure from shell objects, or you can go with extents of diaphragm. We're defining the diaphragm, so we'll go with this coefficients here. So this is the approximate coefficient here, and you can go with the detailed calculation also, so we'll not get into that, but this approximately should satisfy everything. But you can go in the detailed calculations also. I'll make a separate video on that. Now I'm going into the basic wind speed for this building location in Tripura. The basic wind speed is 55 as per the code. Terrain category terrain category 1 is the most open, and terrain category 4 is the most closed. So 1 will have the maximum wind load, obviously. Importance factor is 1. You can see this is the importance factor here. So again, refer to the 875 2015 for all this. So I'm just skipping this little bit forward just to check this, and you can also check my material on wind. So I'll also include this in the video description. You can download this. All the basic important things which are mentioned for the wind load code are mentioned here, and you can calculate the windward coefficient and leeward coefficient accurately, and then you can just apply this here using that. Okay, so you can check that out, and we're just going to click on OK here. So the wind load is defined, and click on OK. So again, I just make a habit of checking the load pattern once again, just to check whether everything is applied properly or not, and then we'll define the next thing. Okay, so next we'll define the response spectrum function. Define and go to functions and response spectrum function. Here we will add a new function here. So you can see these are the some of the codes which you can add the deformed function. So IS 1893 2002, and add new function here. So now this is called this RS, response spectrum, and this zone factor is 0.36 for zone 5 is minimum, soil type is 0.2, medium soil, damping ratio is 5, and now we'll just click on OK. So response spectrum is defined, and we'll delete this spectrum. We'll keep this as default and click on OK. And again, we'll just check the functions and response spectrum whether this is present or not. So response spectrum is defined. So then we'll go to define, and we'll go to load cases, and now you see that these are the load cases here. Dead load, live load, and the seismic load in the two lateral directions. Add a new load case, and now we need to add one load case here. Okay, before defining this, we need to add the mass source here. Just the procedure. So define, and we'll go to the mass source, and we'll just modify this and include element self mass. We'll just exclude this and specify load patterns. Dead load 1, add, and then other dead also 1, and for the in the mass source for the live load, we'll take the live load multiplier as 0.25. Why do we take in this? So go to table number 10 here. I'll just get rid of this, and yeah, go to table number 10 of the code, and you can also have a beautiful definition of seismic weight in the code. It is the sum of the seismic weight of all floors, and seismic weight of a floor is the sum of the dead load of the floor plus an appropriate amount of live load. So what is the appropriate amount of live load? You will find in table number 10. That is, if live load is up to 3, then it's 25%. It is more than 3, then 50%. We're taking live load as 2 for residential building, so it is up to 3, then it is 25%. So that's why in the seismic mass we are adding this. Okay, and then we just click on OK. So the seismic mass source is now defined. Now we can proceed. So next we'll go to define, and we'll go to modal cases, and just modify this case here. You can see, so number of modes, if this satisfies our criteria, that is the first 3 mode contribute 65%. I'll just show you the criterias which have to, which will do the, by the way, the criterias we have to check after the analysis of the structure. By thumb rule, you can take 3 modes for a particular floor. So you can see in this table number 6 of the code, number of and 7.7.5.2. So the number of modes to be used in analysis for earthquake shaking along a considered direction should be such that the sum of total of modal masses of these modes is considered at least 90% of the total seismic mass. So that's one criteria. And for seismic zone 2 and 3 it should be ensured that the first three modes contribute at least 65% of the mass participant factor. And for 4 and 5 we have this thing, first three modes should at least contribute 65%, and there is another clause, natural period should be distant from and the fundamental natural periods of the building in two principal directions should be away from each other by at least 10% of the larger value. So I heard in some of my circles that this particular clause number 2 is going on and revision. So basically we need to identify that the first three modes should contribute 65%. So basically if you take the number of modes as 12, and if it satisfies the criteria, then it's okay. If it doesn't, then you can just increase the number of modes here. Okay, then it should work. So here, so we'll just take this modal subcase as writs here, and then here we'll add three things. Now we'll add this acceleration, and acceleration, and acceleration should be added in the three directions, right? So since we are applying the earthquake in the three directions, so three directions, ux, uy, and uz. So the uz is the vertical element in this accelerations here, and we'll just click on OK and click on OK. Okay, so again just check whether the changes which you have made is saved or not. Sometimes it's important to check that. So now we'll go to define, and we'll define the load cases here, and you can see here we'll now define the add new case, and here we'll define this as the response spectrum here. So the response spectrum load will add here. So RSX, let's go add RSX, and here acceleration U1, and then CQC and SRSS keep this as default. Now there is a lot of confusion around the scale factor, so we'll just look into the original source for the definition of the scale factor as per the Indian code, because there are two definitions of the scale factor. One is as per all the other codes, and one is as per the Indian code. So this varies slightly. First of all, the value of G in this particular scale factor depends, because if you are using the default SI units, and like we use in India, so the unit is 9.81 meter per second square. So this unit is 9.81 in default SI units. But if you're using the American codes, then feet and inches, we do this in imperial units, then it is 980/6 or 981, whatever you want to take. Okay, so that's the variation. So you have to understand, we have to understand that particular thing. So this is taken right from the source. So scale factor in RSA, you can just check out all these nodes to just clarify. So basics, the scale factor is Ig by R. G is acceleration due to gravity, and you can see for us it is 9.81 meter per second square. Okay, I is the importance factor, which is 1, which you already, and R is the response reduction factor, and response reduction factor we have already taken in the earthquake, which is as 5. But I think I had skipped that part. Why is it 5, and from where you can check whether it's 5 or not. So if you're considering special, as per table number 9 of the IS 1893/2016, if you are considering special moment resisting frame, which you generally consider in seismic zone 4 and 5 compulsorily, this should be 5, and for other buildings you can take as 3. So yeah, that's it for the R and the I, and the G already this is 9.81. So this should be very easy, right? But this is different for the Indian code. So for the Indian code, it is Ig by 2R. So that's the only difference which you have in the Indian code and the other codes. This is Ig by 2R. So we can calculate this. You can open the Excel or any sheet document. I use WPS because it's free. Yeah, and yeah. So we have is equals to Ig by 2R. So I is 1, and into G 9.81. And let me just go ahead and bracket that, and we'll just go here, divided by bracket and 2 into R, which is 5, bracket close, and 0.981 is our scale factor. Now there is another clause in our IS code, that if our base shear is less. Now there are a lot of terms for those who are expert, that is okay, and those who are new to this design. So for them, I'll just explain very oversimplify this. So basically the earthquake load is equals to VB, that is the base shear, into the seismic weight. Okay, so VB into seismic weight. VB is the base shear into the seismic weight. So if the seismic weight due to the dynamic load is less than the seismic weight due to the static load, so then you have to apply a multiplying factor. Basically we equate this. Okay, so that we have to do, but then we will find this out after the analysis, whether this is more or this is less. So then we have to multiply this in the scale factor along with this value which we just got, which is 0.981 we got. Then you have to multiply this additional factor that there. Suppose that is the multiply this by the dynamic base shear by the static base shear. So I just read this out. So dynamic analysis may be performed by the time history method or the retrospective method. When either of the methods is used, the design base shear VB estimated shall not be less than the design base shear VB calculated using a fundamental time period A. So VB, this without the hash what do you call this? I forgot. Let's call it this underscore something. So without the VB underscore, it's not underscore. Okay, dash. Let me call it dash. I just forgot the term for this. Okay, so the VB dash or the dynamic base shear. Sorry, normal VB. This one is the dynamic base shear, and the dynamic base shear should not be less than the static base shear. So this is the static base shear VB dash. So we have to multiply this in using the in the x and the y direction, that is the lateral directions. We have to multiply the static base shear by dynamic base shear. So the scale factor 0.981. If our dynamic base shear is less, we have to multiply this by the static base shear by dynamic base shear in all the directions apparently. Okay, so and if we in the vertical direction, the maximum of these two shall be taken. Okay, so yes, this is the predominant thing in the base shear for the three directions apparently. So we are good with this. So we are going RSX here, just to check here RSX, and the scale factor here which we are going to use is 0.981. okay, 0.981. sorry, just I am typing here, and this is the acceleration U1 here. Now the same thing, it's up to you that if you want the response spectrum, all the acceleration in one response spectrum, you can also do that. And but if you want to just for the ease of the load combination part, it's better that we include this separately. Okay, so we'll click on OK, RSX, and add copy of case. We'll do that just RSX. This is RS Y, the other lateral direction, caps lock on, and lateral direction. This will be U2, and this also will be 0.981. I think they take only the first two digits here, and keep this as model QC and SRSS. So this also the description of these two mathematical methods are also described in the course, so there is no problem. And click on OK, and then we'll add a new case here. Add new case, and sorry, we'll add copy of this case, that's easier. So this will be RSZ. So RSZ, this is the vertical direction here, and acceleration is in U3 here, and then click on OK, and then click on OK. So again, just for the convenience, we'll just check the not the load patterns, load cases. We just define load cases, so everything is present here, so we are good to go here. So if you have defined section properties, slab sections, I think we have not defined this. So this is M25. So slab 1, like 150 will do, 150 mm, name it, and 150, and display color. Modifiers, we don't need to add any modifiers here. type is slab, and click on OK and click on OK. Now let's just complete the modeling part real quick here. So this is the let's go to the bottommost part. So in the base level you cannot add the column, we can add the column from from the plinth level itself. So we'll use this option here, quick draw columns, and we'll just choose this let's say the column shape, and we'll just give a column in every intersection here, and same for the beams as well. So let's go here and quick draw beams columns, and in this one we'll just do here beam B300 into 600, and we'll add beams in all the levels here, and then we'll go one story above here, and for the columns here let's add all the columns here like this, and beams also just add like this. So what we can do, we can also copy this thing, but let's assign the slabs also, then we'll copy, then everything will be copied in once, I think. So here you can see a rectangular wall floor, and this is the quick draw floor. So we'll use the quick draw floor here, and our property is slab 150 mm, and we'll assign the slabs. Remember, when you are using a practical structure, don't assign slabs where you have the staircase. So here you can just select this like this. Here you can see in this 3D the columns as well as the slab is selected, and you can use the control plus R button, which is the shortcut for replicate, okay, and control plus R, and then you can just replicate by story, and you can replicate this to story 3, and however apply, don't click on it, just click on 3D and then hover over it, then you can see whether how the application will work. Okay, this is a trick which you can use, and then you can click on OK. Okay, so the modeling part, to complete it we need to select this and assign fixed support. So assign joint restraints, just click on this icon, which is the icon for fixed support, apply and OK. So fixed support has been applied, but if you just move and go down again here also, if you just move around a little bit, you can see the support type has changed to fixed support here. You can see this is the fixed support. Okay, so by the way, if you use the shift and mouse middle button, if you press it, you can just rotate the model, and you can zoom in, zoom out here like this. Okay, so this is the basic things. Now once you have done that, we can just go to analyze, check model, and just select all and OK, and we'll check the model now, and no warnings have been found as of now. And now just click on this to design, analyze and design. You can also click on F5 also. So analyze this model here. So the model has been analyzed here, and you can check the everything, shear force, bending moment, everything you can check here, support reactions, dead load, live load, everything you can check. These results you can check, and after that, after checking, you can just go for the not steel frame design, you can just go for the concrete frame design here. So it will take time for your design, depending upon the depending upon your model size. And in the concrete frame design, you can just check on verify all members passed. So all members have passed the design check. Now you can easily do the detailing of this. You can see start design check, and do the detailing. You can see, suppose this is the AST which has been shown, and from this AST you can do the detailing, or we can do the detailing in RCDC. That's what we are interested in, though, so we'll cover that in a separate video. Thanks for watching. Keep learning. For any doubts, make sure you comment. I try to go through each and every one of the comment, and if that is possible, then I research on that topic and make a video for you. Thank you for watching. Bye bye.